Good morning, distinguished reviewers, participants, and colleagues. My presentation is entitled Extended Reality for Agricultural Supply Chain Education, a systematic review of effectiveness, implementation, challenges, and future directions. So this study was conducted by Loso Judijanto from IPOS, Jakarta, Indonesia, and Sri Nurhayati from IKIP Siliwangi, Cimahi, Indonesia. This paper is presented at IE2C 2026 with the theme Transforming Engineering Education through Tech and Integrity. In this presentation, I will explain the background method, key findings, discussion, and conclusion of our systematic review on the use of XR technologies in agricultural supply chain education. Okay, now let's move on to the introduction. Agricultural supply chains are becoming more complex because they involve production, post harvest handling, processing, logistics, distribution, and value chain coordination. Traditional learning methods such as classroom lectures, manuals, and field demonstrations are still useful but often limited by cost, safety, accessibility, and real world complexity. Extended reality, including virtual reality, augmented reality, and mixed reality, offers new learning opportunities by creating immersive and interactive environments. Through XR, learners can experience realistic agricultural supply chain scenarios without direct exposure to operational risk. Therefore, this study reviews how XR supports knowledge acquisition, skill development, learner engagement, and practical training in agricultural supply chain education. Okay, so next slide is a method. This study used a systematic literature review guided by the Prisma framework to ensure transparency, rigor, and reproducibility. The literature search was conducted using the Scopus database because it provides access to peer-reviewed and high-quality publications. The initial search used broad keywords related to virtual reality and agriculture and identified 678 records. After that, a refined Boolean search string was applied using terms related to XR, agriculture, supply chain, education, training, and learning. The screening process considered a relevance publication period from 2019 to 2026, language, accessibility, and peer-reviewed status. After multi-stage filtering, 30 articles were included for qualitative synthesis. The data were analyzed through thematic coding and comparative synthesis to identify repeated patterns, major themes, and consistent findings across the studies. Okay, let's continue to the next slide. Results 1, learning effectiveness. The first result shows that XR-based education has a positive impact on knowledge acquisition and skill development. Most reviewed studies reported improvements in learners' understanding when XR-supported learning was compared with conventional methods such as lectures, manuals, slides, or videos. XR helps learners understand complex supply chain processes, especially those involving spatial reasoning, sequential tasks, and systems level thinking. It also supports procedural training in post harvest handling, logistics, quality assurance, and operational decision making. However, the effectiveness of XR depends on the learning context, instructional design, technology use, and learner characteristics. Therefore, XR should be seen as a strong pedagogical tool when properly designed. Okay, as for the next results, engagement and experiential learning, uh, The second result highlights learner engagement, motivation, and experiential learning. XR learning environments increase students' attention, interaction, and motivation because they allow learners to participate actively rather than only receive information passively. Through immersive simulations, learners can explore farms, processing facilities, warehouses, and distribution networks in a controlled and risk-free environment. So this helps them understand process flows, identify bottlenecks, and recognize the consequences of operational decisions. However, engagement does not come from technology alone. The reviewed study suggests that XR becomes more effective when combined with structured guidance, clear learning tasks, reflection, and proper instructional support from educators. Okay, the next results shows that it's about supply chain application and challenges. It shows that XR has been applied across different stages of the agricultural supply chain. Production stage application are the most common, including crop management, precision agriculture, and farm level decision making. Post-harvest and processing applications focus on quality grading, storage management, contamination prevention, and workflow optimization. Logistic and distribution applications support scenario evaluation, routing, inventory management, and coordination among supply chain actors. However, several challenges remain. These include high development costs, limited hardware access, poor internet connectivity in rural areas, device compatibility issues, user discomfort, and limited institutional readiness. So these barriers affect the scalability of XR-based education. Okay, the finding suggests that XR can strengthen agricultural supply chain education by connecting theoretical knowledge with practical experience. XR is especially useful for teaching complex, risky, expensive, or difficult to access processes. It allows learners to repeatedly practice decision making and procedural tasks in realistic environments. However, XR should not be treated as a complete replacement for conventional education. Its success depends on pedagogical alignment, infrastructure, instructor readiness, and institutional support. Of course, the discussion also shows that future studies need stronger research designs, long-term evaluation, and broader testing in authentic agricultural training environments to confirm whether XR learning outcomes can be transferred into real professional practice. Okay, this is the conclusion slide. In conclusion, this systematic review shows that extended reality has strong potential to improve agricultural supply chain education. XR supports knowledge acquisition, skill development, learner engagement, experiential learning, and systems thinking. It is useful across production, post-harvest, logistics, distribution, and value chain learning contexts. However, its effectiveness depends on instructional design, technology readiness, and institutional support. Major barriers include cost, hardware availability, connectivity, usability, and scalability. Future research should focus on long term learning transfer, stronger evaluation methods, and practical implementation models that can be adopted by educational institutions and agricultural training centers. Okay, thank you very much for your attention. This presentation has summarized our systematic review on the role of extended reality in agricultural supply chain education. The findings show that XR can provide immersive, interactive, and practical learning experiences that help learners understand complex agricultural processes more effectively. At the same time, successful implementation requires careful planning, appropriate infrastructure, and strong pedagogical design. We hope this study contributes to future development of digital learning, immersive education, and workforce training in the agricultural and agri-food sectors. I welcome any questions, suggestions, or feedback from the audience. Once again, thank you.